Hi, I am V. Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Hyderabad. In this session, we are going to discuss about memory devices. Memory devices are used to store the information. So, based on the particular parameter, that is, if the power is turned off, the data will be erased, or even the power is turned off, the data is not erased. Based on that memory is divided into two types. That is called volatile. Volatile means if the power is turned off, the data, the information will be erased. The type of memory device is called volatile memory. Even the power is turned off, the data is not erased. The type of memory device is called non-volatile memory devices. This is one of the parameter. Again, so different parameters are considered for classifying the different types of memory devices. One of the parameter is whenever the power is turned off, the data is erased or not. That is volatile. Second parameter, while doing the operations, the processing element accesses the information from primary memory devices. So that is called primary, means first time we are accessing. First we are getting the information from primary memory devices. Why? Because the volatile memory devices accessing time is less than accessing time from secondary memory devices. Suppose if you want to access the information from primary devices, that takes 60 nanoseconds, 60 to 80 nanoseconds, whereas secondary memory device is taking 180 nanoseconds to 240 nanoseconds. Means 2 to 3 times more time. The accessing time is more if you want to access the information from secondary memory devices when comparing with primary memory devices. That's why while doing the operations, the processing elements get the information from first primary, then secondary, based on requirement. Based on that, we are classifying the memory into primary memory devices and secondary memory devices. First, we are accessing from volatile memory devices, that's why it is called primary. Second, we are accessing from non-volatile memory devices. One more parameter. If the memory is available within the chip, that is called on-chip memory, either primary or secondary, either volatile or non-volatile. That is limited to the particular processing element. Suppose if you consider 8051 microcontroller, it contains on-chip RAM is 128 bytes. It contains 128 bytes on-chip RAM. And 128 bytes on-chip special function registers. 4 kilobytes read-only memory. This is within the chip. If the memory size is not sufficient at that time, the 8051 is interfacing with the external memory devices based upon requirement or based on the design. Some of the designs, the code size is or the memory size requirement is less than the available memory. That is, in that case, no problem. If the memory size is not sufficient, at that time the processing element needs to be interfacing with the external memory devices. So based on the memory available within the chip or not, that is based on that the memory is divided into either on chip memory. So on chip memory means the memory is available within the single silicon chip. Off chip means the memory is accessing from external peripheral devices. Okay. So we are considering different parameters to classify the memory devices. The main parameter is volatile and non-volatile. We will check one by one. First, volatile memory devices. In that, first one is static random access memory. The static random access memory is made up of 6 MOSFETs. MOSFET 1, 2, 3, 4, 5, 6. In that 6 MOSFETs, these 4 MOSFETs are creating the memory cell for storing the binary information, either 0 or 1. Okay, these 4 MOSFETs creating the memory cell for storing the binary information, either 0 or 1. Next, one MOSFET is designed for controlling the read operation. Another MOSFET is designed for controlling the write operation. Read control and write control. Okay. In static random access memory, the information is stored in the form of voltage. The information is stored in the form of voltage. The advantage is SRAM means SRAM taking less time, like 10 nanoseconds. If you want to access the information from SRAM, it takes 10 nanoseconds while doing the operations. At that same time, if you are using DRAM, dynamic random access memory, that takes 60 nanoseconds. So SRAM is speed. If you want to do the operation, if the information is accessing from SRAM, accessing time from SRAM is less when comparing with DRAM. So SRAM is more speed when comparing with DRAM. So the advantage of the SRAM is more speed when comparing with DRAM. That is, it takes only 10 nanoseconds, whereas DRAM takes 60 nanoseconds. Limitations are SRAM is made up of 6 MOSFETs, so size is more when comparing with DRAM, whereas DRAM is made up of 1 MOSFET and 1 capacitor. So automatically, since it requires 6 MOSFETs, size is more, automatically cost is more. Whatever the extra MOSFETs required, whatever the cost of the MOSFET, cost is more. Power consumption is more. Automatically 6 MOSFETs consumes more power when comparing with 1 MOSFET power consumption. Automatically it requires cooling fans when comparing with DRAM. So all these are the limitations. Okay, size is more, cost is more, power consumption is more, power dissipation is more when comparing with DRAM only. Okay, this is regarding SRAM. Next, dynamic random access memory. In dynamic random access memory, it is made up of 1 MOSFET and 1 capacitor. Here, the information is stored in the form of charge. The information is stored in the form of charge. So, okay. So, DRAM is require only 1 MOSFET. So, size is less. Advantages of the DRAM. So what are the advantages? Small size when comparing with SRAM. Small size. Next one is low cost when comparing with SRAM because it requires only one MOSFET and capacitor, whereas DRAM require 6 MOSFETs. So automatically power consumption is less, power dissipation less, all these are the benefits. Limitations. Here the information is stored in the form of charge. Means the capacitor do the charging and discharging. Means since it discharges the information, it needs to be refreshed periodically. The information needs to be refreshed periodically. So it requires some more time when comparing with SRAM. So it is low speed. That's why it takes 60 nanoseconds to access the information from DRAM. So one more is Ferroelectric random access memory. It is the providing the combination of SRAM and DRAM. SRAM example is cache memory. DRAM example is DDR4 memory device. DDR3, DDR4 that is used in our desktop computers or some computing elements. Okay. Next, we are going to discuss about secondary memory devices. Secondary in the sense, while doing the operations, we are accessing the information from first from the volatile memory, secondary from non-volatile. That's why it is called secondary memory devices. Okay. First priority is given to the volatile memory devices. Okay. So there are different types of memory devices are there. So this is called non-volatile memories. Means even the power is turned off, the data is not erased. So here, based on the fabrication, erasing and programming. So based on these three categories or parameters, these are classified to different types. First one, masked RAM. Masked read-only memory. Okay. Here, the bit generally memory devices are storing the information 0 or 1. So by using masking and metallization, it stores the bit information. So initially it contains one transistor. By default, it is in off condition. That means it stores 0. Whenever we are giving the value more than V input greater than V threshold, means the transistor is conducted and it stores bit 1. Okay. Like that, the masked RAM store the bit information. By default, it stores. By default, it is in off condition. Means it stores 0. Whenever we are giving the input voltage greater than threshold voltage, the transistor becomes on. Means it stores bit 1. Like that, it stores the information. So based on the data given by the end user, the information is programmed into the memory device during manufacturing itself. Okay. Advantage is, since we no need to provide the programming abilities to this memory device, so it is low cost for bulk productions. Okay. So low cost, the memory device cost is very low. Okay, for maximum number of products for manufacturing. Limitation is, end user is unable to program the information, like our antivirus CDs that is coming from manufacturer, or OS CDs that is getting from whatever the supplier, that is not possible to modify that code. Okay, that is the limitation. End user unable to program the memory device. That is pre-programmed during manufacturing itself according to the data given by the end user. Okay, that is the limitation. Unable to program the memory device. Program or modify the information by the end user or customer. Okay, to overcome this limitation, again they are designing programmable read-only memory. Here, nichrome or polysilicon wires. Nichrome or polysilicon wires are arranged in a matrix. These are acts like fuses. So by default, this SRAM stores bit 1. So these are not burn. At that time, that stores logic 1 or bit 1. Whenever the fuses are burned as per the data given by the customer, the fuses are burned and that stores 0. Okay. Here it contains nichrome or polysilicon wires. These are acts as a fuses. These are arranged in a matrix form. These are acts like fuses. So these are not burned by default. At that time it stores 1. Whenever the fuses are burned as per the data given by the customer, that stores bit 0. So advantage is, end user program the memory device as per his requirement, like CDs. In CDs, we are storing our images, videos, audios, whatever the content we want to store. Okay, that is example. Limitation is, only one time. So in case of CDs, one time only we can program the memory device. Once it is programmed, reprogrammability is not possible in that memory device. That is the limitation of the programmable read-only memory. So to overcome this limitation, again we are going for erasable programmable read-only memory. Generally it contains standard transistor or high threshold transistor. By default, the transistor is in off condition. Off means it stores bit 0. By giving the charging, by giving the floating gate of the FET, MOSFET transistor, or we are giving the input voltage greater than the threshold voltage or conducting voltage. At that time, the transistor becomes on it stores 1. Initially, the transistor is in off condition, it stores 0. Whenever you are giving the input voltage greater than conducting voltage or threshold voltage, at that time the transistor becomes conducting and it stores bit 1. Okay. It contains quartz crystal window. Quartz crystal window for erasing the data. So the quartz crystal window is removing from the circuit board and expose it to ultraviolet rays up to 20 to 30 minutes for erasing the data. Okay. EPROM contains quartz crystal window for erasing the data. The quartz crystal window is removed from the circuit and exposed to ultraviolet rays up to 20 to 30 minutes time to erase the data. So advantage is reprogrammable. So during development time, we need to update the code or modify the code until getting the desired response. At that times, if we are using this masked RAM or PROM, we need to purchase more number of memory devices again and again. So indirectly, the development cost is more. So to reduce that one development cost, we need to reprogram the memory device. That's why we are going for erasable, programmable, read-only memory. So advantage is reprogrammability. By the customer or end user. Limitation is it is difficult or it is somewhat complex to remove the quartz crystal window from the circuit board and expose it to ultraviolet rays. Every time we are fixing the quartz crystal window to the circuit and removing that one means fixing and removing means that makes somewhat difficult. So that is the limitation for erasable, programmable, read-only memory. So to overcome this limitation, again we are going for electrically erasable, programmable, read-only memory. Electrically erasable, programmable, read-only memory. So by using electronic signals, we can erase the data. But here, it contains transistor. By default, it is in off condition. Whenever the transistor is in off condition, it stores 0. Whenever you are giving the input voltage greater than 1, the transistor becomes on, it stores 1. Like that, it stores the zeros and ones in the memory device. So to erase the data, to reprogram the memory device, it contains chip erase mode. Chip erase mode. Whenever activating that one, it erases the data by using electronic signal instead of removing from the circuit. Okay, that is the advantage. No need to remove the quartz crystal window from the circuit board. So by using electronic signal, we can erase it. That is the advantage. Advantage is by using chip erase mode, by using electronic signal, we can erase the data simply. No need to remove the components from the circuit board. Limitation is so it erase the data up to register level or byte level. So just assume how much time it will take to, if you want to erase the 1 MB data or 1 kilobyte data. Suppose if you want to erase 1 byte, it takes 1 clock cycle. If you want to erase 1 kilobyte means it requires 1024 clock cycles. If you want to erase 1 megabyte data means 10 into 10, 2 power 20 clock cycles. Again, if you want to erase 1 GB data means 2 power 30 clock cycles. So just imagine how much time it will take if you want to erase 1 kilobyte data or 1 megabyte data or 1 gigabyte data or 1 terabyte data. So to overcome this limitation, we are going for flash memory devices. In flash, internally it contains transistor. By default, it is in off condition. At that time, it stores bit 0. Whenever transistor is on, means input voltage is greater than the conducting voltage. The transistor becomes on. It stores 1. Okay. Like that, it will store the bit information 0s and 1s in the memory device. Here, memory is divided into sectors or pages. Okay. So at a time, it will erase the one page of data or one sector page, one sector data. So like our memory cards, if you want to format the memory card, how much time it will take? Just imagine. Okay, that is the advantage of this flash memory when comparing with E square PROM on previous memory elements. Okay. Next, so memory selection. So based on our design, how much size that is required, either RAM, on-chip RAM, on-chip RAM, ROM or flash. Based on the design size, if it is 2 kilobytes means you can take maximum 8 kilobytes like that as possible. Okay, based on the requirement we can take nearest value of that memory size. Like that we need to choose the memory as per requirement. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.